In this video, which is part 2, we're going to see how enthalpy and entropy help or not help make a reaction occur. This equation relates enthalpy and entropy to free energy. If delta G is less than 0, that means the reaction is spontaneous. How does delta S and delta H help make delta G be less than 0? In case 1, if delta H is greater than 0, note that it doesn't help delta G be less than 0. If delta S is greater than 0, it does help delta G be less than 0. So the temperature will determine whether the reaction is spontaneous or not. So that means that the reaction will occur at some temperature. So stop the video and determine what happens in case 2, 3, and 4. Here are the answers. In case 2, if delta H is greater than 0, that helps delta G be greater than 0. If delta S is less than 0, the minus T times delta S term will be greater than 0. So combining delta H and delta S, delta G will always be greater than 0. That means that reaction will occur at no temperatures. In case 3, if delta H is less than 0, delta S is greater than 0, delta G will always be less than 0. That means that reaction will occur at any temperature. And for case 4, that reaction will occur at some temperatures. A reaction can be favored by enthalpy or entropy or both, so stop the video and answer these 2 questions. Here are the answers. So using this equation, when delta H is less than 0, that helps delta G be less than 0. When delta S is greater than 0, that helps delta G be less than 0. So by using this equation, you, the scientist, can make a spontaneous reaction not occur or a non-spontaneous reaction occur by changing the temperature. So let's do an example. Let's determine the temperature at which the methane combustion reaction occurs or does not occur. Note that this reaction is favored by enthalpy but not favored by entropy. That means there's some temperatures at which this reaction occurs or does not occur. At 25 degrees, this reaction does occur. We can determine the temperature at which this reaction does not occur by plugging in these numbers and solving for T. This equation and calculation shows us that at temperatures greater than 154,230 degrees Kelvin, methane does not undergo a combustion reaction. In other words, that reaction is not spontaneous. Now, if we consider this reaction to be an equilibrium reaction, this reaction would have a very large equilibrium constant. Since the reaction is exothermic, if we add heat, that is, add a product, that's going to make the reaction shift to the reactant side. So at some very high temperature, that reaction will not occur. Now let's do another example, but let me fix something first. Note that water does not freeze at 25 degrees. So stop the video and confirm this calculation. So this calculation shows that the freezing point of water is 0 degrees Celsius. If we look at this reaction as an equilibrium reaction, first note that at 25 degrees the equilibrium constant should be small since water does not freeze at that temperature. Since delta H is less than 0, heat is a product. So applying Le-Chatelier's principle, if we lower the temperature, that is, remove product, that should shift the reaction toward the product side and make water freeze. So you can make a non-spontaneous reaction occur just by changing the temperature. When we looked at equilibrium, we know that equilibrium constant tells us the relative amounts of products to reactants. So let's relate delta G to equilibrium constant. So stop the video and answer these 2 questions. So here are the answers. If a lot of products form, that means KEQ should be greater than 1. That means the reaction occurs. This equation relates delta G to KEQ. We know acetic acid is a weak acid, but if we change the temperature, does acetic acid become a stronger acid or weaker acid? Stop the video and calculate the equilibrium constant at 80 degrees. And here's the answer. So look up or use Hess's law to calculate delta H and delta S for the acetic acid dissociation reaction. Then use this equation and 80 degrees in Kelvin, which is 353 degrees Kelvin, to calculate the new delta G at that temperature. Then use this equation, plug in the new delta G and solve for KEQ. At 80 degrees, the Ka is 3.9 times 10 to 9. Acetic acid is a weaker acid as temperature increases. You probably have some baking soda at home. Is it safe to store your baking soda at room temperature at home? This equation shows the decomposition of baking soda. Stop the video and figure out what you would calculate to find out. So here's the answer. You will want to calculate delta G to find out. And if you use this equation, set delta G equal to 0 and then solve for T. The temperature which baking soda decomposes is 386 degrees Kelvin or 113 degrees Celsius. Does an egg cook by itself? In other words, is this reaction spontaneous? At room temperature, the answer is no. As we know, we can cook an egg, that is, make this reaction occur if we heat it up, raise the temperature. Let's do this practice problem. Ammonia is a base and used to make fertilizer, so stop the video and answer these two questions. So here are the answers. For the first question, ammonia does not decompose at room temperature. At 25 degrees, delta G is positive. For the second question, ammonia should be stored at low temperature. Note that delta H is positive. That means heat is a reactant. Increasing the temperature shifts the reaction to make more products, which increases the equilibrium constant. Decreasing the temperature does the reverse, and also makes ammonia decompose slower. Another way to make a non-spontaneous reaction occur is to use the energy from a spontaneous reaction. Reaction 1 is non-spontaneous. Reaction 2 is spontaneous. Add reaction 1 to reaction 2, and delta G for this third reaction is less than 0. That means this third reaction is spontaneous. Here is an example from biology of using a spontaneous reaction to make a non-spontaneous reaction occur. The first step of glycolysis is not spontaneous. Our body uses the energy from the ATP hydrolysis reaction to make that first step of glycolysis occur. So stop the video and review how the sum of those two reactions gives us a new reaction that occurs spontaneously. I'm going to guess you've heard the term high energy phosphate bond in your biology class to describe ATP. The phosphorus oxygen bond in the triphosphate part of ATP is a fairly high energy bond, but it's not as high energy as, say, a CO bond. So it's not the phosphate bond in ATP that supplies the energy to make biology reactions occur. It's the ATP hydrolysis reaction which supplies the energy to make other reactions occur. So let's review. Stop the video and answer these 5 questions. And here are the answers. I'm sure you did well.